Alright, so we should be pretty close to done with our foldable, but everybody left class today at different parts. So hopefully you will be able to see the examples that you were unable to see in class and add them to your foldable. So let's start off with the first one. The first one is asking us to go, how many grams of NO2 are produced from 250 grams of N2 gas? So in this problem we are going from grams to grams. So this is going to be the bottom right hand part of your foldable. Alright, the first step in every chemical reaction is the first step in every stoichiometry problem is to write down a balanced equation. Since it says NO2 is produced, that's telling us it is a product. Okay, it says it is produced from N2 gas, so that's telling us it is a reactant. Well, my oxygen didn't just come out of thin air, it had to come from somewhere, so that means that oxygen must also be a reactant. Alright, well now I need to balance it. Now why did I just write down O2? Because oxygen is a diatomic molecule, which means he's never ever by himself, so he has to be in 2. So now I need to balance this guy. I need to start off with balancing my nitrogens. To balance my nitrogens, I have 2 on the left, 1 on the right, so I need to put a 2 right there. That fixes my nitrogens, but it messes up my oxygens. I now have 4 oxygens on the right and only 2 on the left, so I need to put a 2 right there. Alright, so now I have my balanced chemical equation, so I can start my conversion process. The first step in every single conversion is to write down what we are starting with. So we're going to write down 250 grams of N2. Okay, where are we going? We are going to grams of NO2. Alright. The first part we always need to do is remember the whole point of doing conversions is we are trying to convert one unit from the next. So we need our conversions to cancel out. So right off the bat, I need my grams of N2 to cancel out. So I'm going to put it on the bottom. And I'm going to put what I want on the top. Well, I don't want grams of N2. I don't even want moles of N2. I want grams of NO2. But the weird thing about stoichiometry is you can only change one part of the unit at a time. So right now we're in grams of N2, so we need grams of N2 on the bottom. Well, we can't go straight from grams of N2 to grams of NO2. So the key thing is you always need to be in moles. If you're not in moles, you need to go to moles in the first step. So we need moles. So I've changed the first part of my unit here. Well, you can only change one part at the time, so that means my N2 needs to stay the same. So if we look at the periodic table, we can see that 1 mole of N2 is equal to the grams of N2. Nitrogen is 14.01, but we have 2 nitrogens, so that means it is 28.02. Okay? This unit cancels out this unit. We're left with moles of N2, but we don't want moles of N2. So I need another conversion factor. And again, I need my moles of N2 to cancel out, so I'm going to automatically put it on the bottom. Now I can't go from moles of N2 to grams of NO2 because I need to change my column from N2 to NO2. So I need to use a mole ratio. I'm going to put what I want over what I have. And then to get these numbers, I look at my balanced chemical reaction. The coefficient in front of my NO2 is a 2. Coefficient in front of my N is a 1. This unit cancels out this unit. We're left with moles of NO2. But that's not what we want. We want grams of NO2. So I need to look up the molar mass of NO2. So 1 mole of, and I'm running out of room, we'll just do this on the next. So I need my mole of NO2 on the bottom, and I need my grams of NO2 on the top. Again, I'm going to look at my periodic table to figure this out. Nitrogen is 14.01, oxygen is 16, but there are 2 of them. So if I do 14.01 plus 16, I'm going to get 46.01. Okay? This unit cancels out this unit. We're left with grams of NO2, which is what we wanted. So now we are ready to put this in our calculator and do the math. So if I do 250 divided by 28.02 times by 2 times by 46.01, I get an answer of 821.02. But I need to check significant figures. 250, which is the only number given to me in the problem, has 2 significant figures, which means I can only keep 2. So I need to round this to 820 with my unit of grams NO2. All right, so let's look at the next one now. The first step we always need to write a balanced chemical equation. And actually, the next two ones use the exact same balanced chemical equation. So, NaCl is produced. That means it's a product. And it is being produced from chlorine. Well, my sodium didn't just appear out of nowhere. It had to be a reactant as well. So now I need to make sure my equation's balanced, which it's not. I have 2 chlorines on the left, only 1 on the right, so I need to add a coefficient right here, which also changes my sodium, so I need to balance my sodiums on the left side. Alright, so now I'm ready to do my stoichiometry. First step in every conversion is to write down what we're starting with, and we are starting with 35 grams of chlorine. And we are going to moles of sodium chloride. So we are going from grams to moles. So this is going to be in the bottom left-hand corner of your foldable. Okay. So first off, we're not in moles. If we're not in moles, the only way we can do stoichiometry is if we're in moles. We're not in moles, so we have to convert. So I need grams of chlorine on the bottom, so my units will cancel. Moles on the top. 1 mole of chlorine. You look at the periodic table. Chlorine is 35.45. But we don't have 1 chlorine, we have 2, so altogether that's going to be 70.9. This unit cancels out that unit. We're left with moles of chlorine, but we don't want moles of chlorine, we want moles of sodium chloride. So I need a conversion, a mole ratio conversion, allows me to go from moles to moles. So I put what I want, my moles of sodium chloride, on top of what I have, which is my moles of chlorine. I use my balanced chemical equation to get my mole ratio. The coefficient in front of sodium chloride is 2. The coefficient in front of chlorine is 1. This unit cancels out that unit. We're left with moles of chlorine. So now we just are ready to do the math. So we are going to do 35 divided by 70.9 times by 2, and we get an answer of 0.9873. So now I need to check my significant figures. 35 only has 2, so we get to keep these 2 guys. So my answer is 0.99 moles of sodium chloride. Right. Well, I'm not going to erase all of this because we get to use the same balanced equation because it involves the same reaction. But let's look at the third bullet point now. Alright, so the third bullet point says how many grams of sodium chloride are produced from 5 moles of sodium. We don't have to rewrite the equation because it's the same equation. We just have to start in a different spot. So we always write down what was given to us in the problem, and we were given 5 moles of Na. So 5 moles in A. Where in the world are we going? We are going to grams of sodium chloride. Alright, the first step is to always go to moles. We're already in moles, so we don't have to do that first step. We can just go ahead and use our mole ratio now. We put the moles of what we want over the moles of what we have, and then we use our equation. So the coefficient in front of sodium chloride is a 2. Coefficient in front of sodium is a 2 as well. That unit cancels out that unit. Now we just need to go to grams. So I do my molar mass, which we found from the periodic table. 1 mole of sodium chloride has a mass of, sodium is 22.99, chlorine is 35.45. Since there's only 1 of each, you just add them together. We get a mass of 58.44. This unit cancels out this unit, and we are left with grams of sodium chloride, which is what we want, so we put this in our calculator. We're going to do 5 times 2 divided by 2 times by 58.44, and we get an answer of 29.2, or not 29.2, 292.2. But before we have our final answer, we need to check significant figures. 5 only has 1 significant figure, so I only keep this spot. So I'm going to round this to 300 and then grams sodium chloride. Alright, let's look at the last problem now. The first step in stoichiometry is to write a balanced equation. So H2O is being produced from H2. Well, the oxygen didn't appear out of nowhere, so it must also be O2. Now I need to balance it, fix my oxygens, and then I need to fix my hydrogens. Alright, so now we need to start the stoichiometry process. The first step is to write down what was given to you in the problem, which is 5 moles of H2. Where in the world are we going? We are going to moles of H2O. Well, in stoichiometry, we have to be in moles in order to change our compound. Well, we're already in moles, so we get to skip that step. So now we just have to do our mole ratio. I'm going to put the moles I want. I want H2O. I have H. So now I just need to use my balanced chemical equation to come up with my numbers. The coefficient in front of H2O is a 2. The coefficient in front of H2 is also a 2. This unit cancels out this unit. We're left with moles of H2, which is what we wanted. So this is an easy one-step conversion. And honestly, the math is easy as well. 5 times 2 divided by 2 is going to give us 5 moles of H2O. Alright, so hopefully this was helpful. Hopefully this allows you to kind of see the steps. Every stoichiometry problem is a little bit different. It is based on what you are given and what you are ending with. A series of steps changes, but we always do the same process. You always write a balanced equation. You always need to make sure you're starting with moles. You need to use your mole ratios. You have to convert to what you want, so on and so forth. So it's the same process. It just depends on what you're given and what you're ending with.